Binomial Theorem, presented by ᵉᵗᵉ, Binomial and Honey Lovely Flores of BS Math 1-1. What is binomial? A binomial is a polynomial with two terms. For example, 5y cubed minus 3 is an example of a binomial. What happens when we multiply a binomial by itself many times? Example, a plus b. A plus b is a binomial. The two terms are a and b. Let us multiply a plus b by itself using polynomial multiplication. Example, a plus b times a plus b equals a squared plus 2ab plus b squared. Now, take that result and multiply by a plus b again. That's a squared plus 2ab plus b squared times a plus b equals a cubed plus 3a squared b plus 3ab squared plus b cubed. And again, a cubed plus 3a squared b plus 3ab squared plus b cubed times a plus b equals a raised to the power of 4 plus 4a cubed b plus 6a squared b squared plus 4ab cubed plus b raised to the power of 4. The calculations get longer and longer as we go, but there is some kind of pattern developing. That pattern is summed up by the binomial theorem. The binomial theorem: a plus b to the power of n equals summation of k equals 0 going up n, close parenthesis, n divided by k, close parenthesis, a to the power of n minus k, multiplied by b raised to the power of k. Don't worry, it will all be explained. Exponents. First, a quick summary of exponents. An exponent says how many times to use something in a multiplication. Example, 8 raised to the power of 2 equals 8 times 8 equals 64, wherein 8 is the base and 2 is the exponent or index or power. An exponent of 1 means just to have it appear once, so we get the original value. Example, 8 to the power of 1 equals 8. An exponent of 0 means not to use it at all, and we have only 1. Example, 8 to the power of 0 equals 1. Exponents of a plus b. Now, onto the binomial, we will use the simple binomial a plus b, but it could be any binomial. Let us start with an exponent of 0 and build upwards. Exponent of 0, when an exponent is 0, you get 1. A plus b to the power of 0 equals 1. Exponent of 1, when the exponent is 1, we get the original value unchanged. A plus b to the power of 1 equals a plus b. Exponent of 2, an exponent of 2 means to multiply by itself. See how to multiply polynomials. Exponent of 3, for an exponent of 3, just multiply again. A plus b to the power of 3 equals a squared plus 2ab plus b squared. Multiply a plus b equals a cubed plus 3a squared b plus 3ab squared plus b cubed.
So let's talk about the pattern of binomial theorem. In the last result, we got a to the power 3 plus 3a to the power 2b plus 3ab to the power of 2 plus b to the power of 3. And now we notice that the exponent of a, they are start at 3 and go down to 0. This is the exponent of a. For a to the power of 3 is 3, then 3a to the power of 2b is 2, plus 3ab to the power of 2 is 1, plus b to the power of 3 is 0. Then likewise the exponent of b go upwards, so 0, 1, 2, and 3. This is the exponent of b. For a to the power of 3 is 0, then 3a to the power of 2b is 1. Then 3ab to the power of 2 is 2. Then b to the power of 3 is 3. Now, what are the different exponent a and b? So, the exponent a start at 3, go down. Then, the exponent b is start to 0, upwards. If we numbers the terms 0 to n, we get this. First step, we need to input exponent a. Next, the terms of k equals 0 in exponent a is a to the power 3. Then the terms of k equals 1 is a to the power of 2. Then the k equals 2 is the a. And last is the k equals 3 is 1. The second is exponent b. Then the terms of k equals 0 in exponent b is 1. Then k equals 1 is b. Next, the k equals 2 is b to the power of 2. Then the last is k equals 3 is b to the power of 3. And now, which can be brought together into this? A to the power n minus k and b to the power of k. They are the examples. Is when the exponent n is 3, the terms are, because the exponent n is 3, start from 0 to upwards, and now we will use the exponent b. So the first step, input the k equals 0 to k equals 3. The next is write the formula by the column. So, a to the power n minus k, b to the power of k. Next is write a, then the exponent n is 3, so write 3. Then the first column k is 0, so write 0, then b to the power of 0. So next column is write a to the power of 3, then minus k equals 1, b to the power of 1. The third is a to the power of 3 minus k equals 2, b to the power of 2. Then the last is a to the power of 3, then minus 3 because the k equals 3, then power b of the power 3. So the next is how to solve it. First we will do input the a, then 3 minus 0 is 3, so write 3. B to the power 0 is not allowed, so a to the power of 3 na lang. Then the second is write a, then 3 minus 1 is 2, so write 2, then b to the power 1 is b na lang. So the third is write a, because 3 minus 2 is 1. So, bring down natin siya ang a. Then, b to the power of 2. So, the answer is a, b to the power of 2. Then, the last is write b to the power of 3, because 3 minus 3 is 0. Then, cancel out. Then, copyright the b to the power of 3. So, next topic, it's about coefficient. So far, we have a to the power 3 plus a to the power 2b plus ab to the power of 2 plus b to the power of 3. But we really need a to the power 3 plus 3a to the power of 2b plus 3ab to the power of 2 plus b to the power of 3. we are the missing numbers which are called coefficient. Let's look at all the results we got before from a plus b to the power of 0 up to a plus b to the power of 3. So this one, start from 1, go down to the a plus v, followed by the a to the power of 2 plus 2ab plus b to the power of 2. Then the last is a to the power of 3 plus 3a to the power of 2b plus 3ab to the power of 2 plus b to the power of 3. And now look at just the coefficient with a 1 where a coefficient was not shown. So this one, start from number 1, go down to the 1a plus 1b, followed by the 1a to the power of 2 plus 2ab plus 1b to the power of 2. Then the last is 1a to the power of 3 plus 3a to the power of 2b plus 3ab to the power of 2 plus 1b to the power of 3. They actually make a Pascal triangle. So input the 1 and the second is a 1 and 1. The third is 1, 2 and 1. And the fourth is 1, 3, 1. Then the last is input the 1, then 1 plus 3 equals 4, so you need to add. And add the 3 plus 3 is 6. Then next is 3 plus 1 is 4, then input the 1. So each numbers just the two numbers above added together except for the edges which are all 1. Let us try something new, an exponent of 4. Exponent A, start from 4, 3, 2, 1, and 0. So a to the power of 4 plus a to the power of 3 plus a plus 1. Then the exponent b is start from 0 to 4. So a to the power of 4 plus a to the power of 3b plus a to the power of 2 b to the power of 2 plus ab to the power of 3 plus b to the power of 4. Then the coefficient is start from 1, 4, 6, 4, 1. And a to the power of 4 plus 4a to the power of 3b plus 6a to the power of 2 b to the power of 2 plus 4a b to the power of 3 plus.
As a formula, our next task is to write it all as a formula. We already have the exponents figured out, which is a to the power of n minus k times b to the power of k. But how do we write a formula for find the coefficient from Pascal's triangle? Well, there is such a formula, which is n chose k equals to n factorial over k factorial times n minus k factorial. It is commonly called n chose k because it is how many ways to choose k elements from a set of n. The exclamation mark means factorial. For example, 4 factorial is equal to 4 times 3 times 2 times 1, and it is equal to 24. And it matches to Pascal's triangle, which is like this. This is the triangle for factorial in Pascal's triangle. Note how the top row is row 0 and also the leftmost column is 0. Let's have an example. Example, row 4, term 2 in Pascal's triangle is equal to 6. Let's see if the formula works. The formula is n chose k is equal to n factorial over k factorial times n minus k factorial. Then we substitute the number and it is equal to 4 chose 2 equals to 4 factorial over 2 factorial times 4 minus 2 factorial. 4 minus 2 is equals to 2. So it is 4 factorial over 2 factorial times 2 factorial. And 4 times 3 times 2
times 1 is equal to 24. 2 times 1 times 2 times 1 is equal to 4. So 24 divided by 4 is equal to 6. Let's have another example. Example which is 7 chose 3. So 7 factorial over 3 factorial times 7 minus 3 factorial. 7 minus 3 is equals to 4. So it is equals to 7 factorial over 3 factorial times 4 factorial. 7 times 6 times 5 times 4 times 3 times 2 times 1 is equals to 5040. 3 times 2 times 1 times 4 times 3 times 2 times 1 is equals to 144. So 5040 divided by 144 is equals to 35. Putting it all together. The last step is to put all the terms together into one formula. But we are adding lots of terms together. Can that be done using one formula? And the answer is yes. The handy sigma notation allows us to sum up as many terms as we want. This is the sigma notation. This symbol is called sigma, means sum up. The values are shown below and above the sigma. The summation of n, and it says n goes from 1 to 4, which is 1, 2, 3, and 4. So now we add them up. 1 plus 2 plus 3 plus 4 is equals to 10. Now it can all go into one formula, which is the binomial theorem formula. The sigma signs tell us to add up the terms. The n chose k is from n chose k equals n factorial over k times n minus k factorial. This one means reduce the a term and increase the b term each time. It won't make much sense without an example, right? So let's try using it for n equals 3. A plus b to the power of 3 is equals to the summation of k equals 0 goes to 3. Then 3 chose k times a to the power of 3 minus k times b to the power of k. Then let's substitute. 3 chose 0 times a to the power of 3 minus 0 times b to the power of 0 plus 3 chose 1 a to the power of 3 minus 1 times b to the power of 1 plus 3 chose 2 times a to the power of 3 minus 2 times b to the power of 2 plus 3 chose 3 times a to the power of 3 minus 3 times b to the power of 3. 3 chose 0 is equals to 3 factorial over 0 factorial times 3 minus 0 factorial. And 3 chose 1 is equals to 3 factorial over 1 factorial times 3 minus 1 factorial. Then 3 chose 2 is equals to 3 factorial over 2 factorial times 3 minus 2 factorial. And last, the 3 chose 3 is equals to 3 factorial over 3 factorial times 3 minus 3 factorial. And it is equals to 6 over 6 times a to the power of 3 times b to the power of 0 plus 6 over 2 times a squared times b to the power of 1 plus 6 over 2 times a to the power of 1 times b squared. Then plus 6 over 6 times a to the power of 0 times b cubed. Then it is equals to 1 times a cubed times b to the power of 0 plus 3 times a squared times b to the power of 1 plus 3 times a to the power of 1 times b squared plus 1 times a to the power of 0 times b to the power of 3. Then the final answer is a cubed plus 3a squared b plus 3ab squared plus b cubed. It is usually much easier just to remember the pattern. The first term's exponent starts at n and go down. The second term's exponents start at 0 and go up. Coefficients are from Pascal's triangle or by calculation using n chose k equals n factorial over k factorial times n minus k factorial. Let's have an example. What is y plus 5 raised to the power of 4? First, let's refer to the Pascal's triangle. Since the given is raised to the power of 4, we will find the number 4 in Pascal's triangle. And here is the number 4. And the numbers here indicates the coefficients that we will use to calculate the y plus 5 raised to the power of 4. To find the y plus 5 raised to the power of 4, let's start with the exponents. And let's remember that the first term's exponent start at 4 and go down. And the second term exponents start at 0 and go to the 4. Since the given power is 4, then y raised to the power of 4 times 5 to the power of 0. Then y cubed times 5 to the power of 1. Then y squared times 5 squared. Then y to the power of 1 times 5 cubed. Then y to the power of 0 times 5 to the power of 4. Next, we include the coefficient, and based in the Pascal's triangle, the coefficients are 1, 4, 6, 4, and 1. Then it is now a 1y to the power of 4 times 5 to the power of 0 plus 4y cubed times 5 to the power of 1 plus 6y squared plus 5 squared plus 4y to the power of 1 times 5 cubed plus 1y to the power of 0 times 5 to the power of 4. 5 to the power of 0 is equals to 1. 1y to the power of 4 times 1 is equals to y to the power of 4 plus 4y cubed times 5 is equals to 20y cubed plus 6y squared times 5 squared is equals to 150y squared plus 4y to the power of 1 times 5 cubed is equals to 500y plus 1y to the power of 0 is equals to 1. 5 to the power of 4 is equals to 625. So 625 times 1 is 625. Then, the final answer is y plus 5 to the power of 4 is equals to y to the power of 4 plus 20y cubed plus 150y squared plus 500y plus 625. Another example. What is 2x minus 3y raised to the power of 5? Since the exponent is 5 in the problem, we will look for 5 in the Pascal's triangle. Then, let's substitute the exponent and the coefficients. 1 times 2x raised to the power of 5 times negative 3y to the power of 0 plus 5 times 2x to the power of 4 times negative 3y to the power of 1 plus 10 times 2x to the power of 3 times negative 3y raised to the power of 2 plus 10 times 2x squared times negative 3y cubed plus 5 times 2x to the power of 1 times negative 3 to the power of 4 plus 1 times 2x raised to the power of 0 times negative 3y to the power of 5. Let's just cancel the term that is raised to the power of 0 since it is just equal to 1. 1 times 2x to the power of 5 is equals to 32x to the power of 5. 5 times 2x to the power of 4 times negative 3y to the power of 1 is equals to negative 240x to the power of 4 times y. Then, 10 times 2x cubed times negative 3y squared is equals to negative 720x cubed times y squared. Next, 10 times 2x squared times negative 3y cubed is equals to negative 1080x squared times y cubed. Next, 5 times 2x to the power of 1 times negative 3y to the power of 4 is equals to 810xy to the power of 4. Then last, negative 3y to the power of 5 is equals to negative 243y to the power of 5. And the final answer is 2x minus 3y to the power of 5 is equals to 32x to the power of 5 minus 240x to the power of 4y minus 720x cubed y squared minus 1080x squared times y cubed minus 810xy to the power of 4 minus 243y to the power of 5. We may also want to calculate just one term. For example, what is the coefficient for x cubed in 2x to the power of 8 plus 4? The exponents for x cubed are 8 minus 5 equals 3 for the 2x and 5 for the 4. And it is 2x cubed times 4 to the power of 5 because based on the Pascal's triangle, and if we follow the steps from the examples, we can come up in these terms. We don't need to calculate all the other values since we only want one term, right? And let's not forget 8 choose 5 because 8 minus 5 equals to 3, which is the exponent of x cubed term that we want to calculate. Then, let's calculate. N factorial over k factorial times n minus k factorial is equals to 8 factorial over 5 factorial times 8 minus 5 factorial. 8 minus 5 equals to 3. So, 8 factorial over 5 factorial times 3 factorial. We can just cancel the 5 factorial in numerator and denominator. Then, 8 times 7 times 6 over 3 times 2 times 1 is equals to 56. And we get 56 times 2 x to the power of 3 times 4 to the power of 5. 2x to the power of 3 is equals to 8x cubed. 4 to the power of 5 is equals to 1024. Then, let's multiply 56 times 8x to the power of 3 times 1024. And it is equals to 458,752x cubed. The coefficient for x cubed in 2x to the power of 8 plus 4 is 458,752.
As b to the power of 4. This topic is about geometry. The binomial theorem can be shown using geometry. In 2 dimension, a plus b to the power of 2 equals a to the power of 2 plus 2ab plus b to the power of 2. So these show our examples of 2 dimensions. X is 3 dimensions, so a plus b to the power of 3 equals a to the power of 3 plus 3a squared b plus 3ab squared plus b to the power of 3. And now, they are the 5 boxes that show of 3 dimensions. So, the next is 4 dimensions. So, a plus b to the power of 4. So, now, let's proceed the advanced examples. And one last, most amazing example. The examples, formula for Euler's number. We can use the binomial theorem to calculate Euler's number. For the Euler's number, if E equals 2.71, the digits go on forever without repeating. And it can be calculated using 1 plus 1 over n raised to the power of n. So it gets more accurate the higher the value of n. That formula is a binomial, right? So let's use the binomial theorem. So this is the binomial theorem, the formula. First, we can drop 1n minus k as it is always equals to 1. So this one. And quite magically, most of what is left goes to 1 as n goes to infinity, like this, which just leaves that if you remember 1 as n goes to infinity. So the n is 1, you need to input 1 above, and the k is 0, 1, 2, 3, 4, and so on. Equals 1 plus 1 plus 1 over 2 plus 1 over 6 plus 1 over 24. And now the first few terms we get 2.70. So this is the end of our discussion in a binomial theorem.
Thank you for watching.